Okay, so good evening, guys. I hope you all are good. Just one more minute. I'm just setting up my writing pad and we will directly start. भाई हर्षल क्या हो गया?
Yash? Hello. Hi, Yash. Hello.
Said he is joining in 2 minutes.
Hello. Hello. Hello.
Hello, guys. Hi. Sorry, I had to go out for a minute. Atiksha, is it the reason why you called?
Yeah, I called you.
Actually, I just moved away from the laptop and that's why I
Yeah,
was not
that's
able
why I
to
was
hear you.
calling your name.
Acha, acha, I'm sorry, I'm sorry. Yeah, please tell me.
No, no, it's okay.
Okay, so guys, just a quick update. Like that, four questions that are left. No, that I really need to get it clear. Till now, I did not got time to ask because the guys to whom I discussed, Vanshika and other people, they are not really available right now, and I did not get the email response from the faculties too. So let's go on with estimation theory. In either way, there are only single digit questions that we need to discuss, right? That are left. So we have ample of time in immersion also and here also. So we will. I promise you to cover that as soon as possible. But for today, we'll be starting with the estimation theory. Uh, is my voice properly audible to you? And I'm just sharing the screen. Please acknowledge, is the screen also visible to you or not? Okay, so guys, just please give me a quick heads up if the screen is properly visible to you all, so that we can start.
Yeah, it's visible.
Great, great, great. So let's start with the topic that is relatively good in itself, that is estimation theory. And यार honestly एक चीज बताऊँ ना, मैं तो estimation theory is one of the easiest topic that I feel like. There are multiple reasons behind it. So just a minute, let me start. Um, okay. Just a minute, guys. I'm just setting up my. Okay. Is it? Yes. Okay. Yes, perfect. Okay. So I was saying that the estimation theory is one of the most easiest topic that I feel like, because here only few formulas are there and we are done with all the things. Also, the practical derivation of it is very simple in itself, and you just need to focus for a minute, and the other minute you will feel like I can solve all the other derivations with just one derivation. So moving forward with that approach in our mind, that this subject or this topic is quite scoring for us, let's move ahead and start with the estimation theory. So what I'll do, I'll cover the theory first. Okay, theory first, followed by the derivations in the theory itself, and in the part 2 we'll solve the tutorial sheet 4. Also, I checked the tutorial sheet questions are 9 only, so they are not very much in itself. Like we won't invest much time in tutorial sheet, because since there are only 9 questions, we'll be covering it very quick. So I'll try to wrap up all these topics today. If not tomorrow, along with that 4 questions, everything will be wrapped up. Got it? Shall we move ahead?
Yeah, bro.
Okay, Harshal and Prasanna, I hope you are recording this session, because there are some guys who watch it in the morning. So if not, please start the recording from now. Okay, so in the estimation theory, uh, as this word has three words in itself. One is estimate. Okay, one is estimator, and third is estimation. Let's go with this one by one. I'll go slow, don't worry about it, and we'll understand each and every topic in a proper depth, so that we do not remember the formula at any time. We know what to do, we know the derivation, we'll get the formula if we do not remember the formula at that instance. So let's first talk about what is estimate. So estimate, that is a particular. देखो, what is basically estimate? When you have a billing or something, you just estimate means you just roughly calculate what can be the expense or what can be some quantity. So estimate is that the same as our real time problem. So it is the value that we need to find, and that is an approximate value. So it is an approximate value that we calculate. Estimate is clear. In very layman terms, I have given you the definition so that you can connect it better. Talking about estimator, so estimator is basically a statistics for which we need to find our estimate. Basically estimator क्या होता है? It is a statistics means different statistics we use, right, to calculate or to finalize some particular result. So the statistics that are used, like we can say we use mean, we use median, we use sigma square, no, we use standard deviation, variance, and different statistics that we use to calculate the estimate. That is an estimator. So estimator is the statistic for which we find estimate. Okay, got it? And third is estimation. So what is estimation? Estimation is basically, देखो, everything starts with a case. Whenever a medicine comes into the market, it is first, just a minute guys, let me, yeah. So what happens, and on the first place is that out in the population, when a medicine occurs, first of all it is tested on a sample. right? And on the result that we get from the sample, we conclude that what can be our population. Got it? So estimation is the same thing. Estimation defines this all concept. It says that if we are given a sample, if we are given sample and using it when we draw, let me, yeah, and using it when we draw a conclusion that what can be my population, mu and sigma. I hope you are now cleared with the symbols that we used and will be using along. But if not, I'll let you know. But first of all, uh, are we all clear with all these three estimate, all these three keywords? Guys, there are, I guess, 15 of them. Please, can any of you acknowledge me so that I can be in a better position to move ahead?
Yes, can you quickly summarize like whatever you told? Sorry, I joined right now. But you can
Sure,
give
no
me.
problem. So basically, estimation theory has three things. One is estimate, second is estimator, and third is estimation. So estimate, what is estimate? It is a rough or approximate value that we calculate, right? So this is my estimate regarding my expenses. This is my estimate regarding my plans of maybe going to go out somewhere. So this is basically an estimate that we draw after some calculations, right? Then what is estimator? So estimator is the statistics, or I can say the algorithm or something like that, that we apply to find that estimate. That is an estimator. And estimation is that thing that if we are given a sample, like for example we are given the data of 20 peoples and we are given sample mean and sample variance of it, and we are calculating and estimating the values to conclude for our population data, then that particular thing is called as estimation. Is it clear to you all once again?
Yes, yes. Thank you.
Okay, other guys, anyone? कौन है मैं देखते नहीं हूँ.
Done, done, done. Yep.
Done. Great. चलो, let's move ahead. तो एक एग्जाम अभी, ठीक है, let's come on to the point, but before that I want you to understand few keywords or symbols that will be frequently using. I hope you like, I know you all know, but again, so what is this? क्या बोलते, what it is?
New.
Guys, tell.
Mu.
Mu. So what it represent? Basically it represent population mean, right?
Yeah, population.
Okay. And what is the population standard deviation or population standard deviation or population variance? How do we denote it? We
Sigma.
denote it by sigma or sigma square. So sigma is standard deviation and variance is sigma square. Now coming towards, what is sample mean? How do you define like how do you denote a sample mean?
X bar.
mu
X
upon
bar.
x.
No, sorry, x bar. Okay.
फिर वो जो mu upon root n था वो
अरे
किस में?
वो तो SEM था. मैं फिर से भूल गया उसका फॉर्मूला. इट इज स्क्वायर्ड एरर मीन. दैट इज बेसिकली यूज्ड व्हेन वी आर गोइंग फॉर सेंट्रल लिमिट थ्योरम. सो इट इज नॉट हियर.
Okay.
Sample mean is not that thing, bro. You are just mixing up things. Please separate it out and okay, like understand fresh here. So sample mean is x bar and sample variance. How do we signify sample
S.
variance and the
S.
sample standard deviation? Yeah. So my sample standard deviation is S and sample variance is S square. Got it? And again, when we are given n population, so n denotes number of number of count in a sample. Okay, anything. Got it? ठीक है. These all keywords are known to you. And again, there are multiple distributions that I'll use. One is Z, one is T, one is chi-square. Okay, so I hope these three you at least have at least heard about it till now, right? Okay, fairly good. Let's move forward to the case. So I just want you to understand one thing that I understood. What is this alpha?
Significance value.
Significance value. Do you know what it is? Like, you know what it is called, but you know what it is actually. Acha, you have heard p value,
Yeah.
right? You have heard p value. So basically, this p value denotes, I'm just not going off topic, it is in topic only, so listen carefully. This p value, in this p denotes the probability of our test to get rejected. Got it? Got it? This is our p. Understand this very carefully, and this is our alpha. This probability of our test to get of our test to get rejected is alpha. That means if we do certain test, maybe using hypothesis testing or somewhere, and our test is likely to fail, then if you remember, in hypothesis testing we say that it is falling into the rejection region, or we call it as an alpha, right? Got it? Chalo. Great. So there are two things. One is confidence level, confidence interval, and second one is level of significance. See this confidence interval, what it is, you know. Confidence interval is something that I am 100% confident about. If I say my confidence interval is 90%, that means I am saying I am 90% sure that tomorrow rain will happen. Got it? Got it? So this is my probability of success. What is my success? My success is that tomorrow rain will happen, and my confidence is 90% chances that rain will happen. So in this, what is the probability that rain will not happen? 10% chance, correct? So 10% chance denote my probability of failure, correct? And what is the probability of failure? That is alpha. That's why whenever we have a confidence interval and we need to find alpha, we do 1 minus confidence interval and we calculate this alpha, right? Just a minute, guys. Just a minute. Okay, guys. Yeah. So, are you guys clear with what we discuss here? What is alpha? Do you actually got what is alpha?
Yes, yes.
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 Yeah.
Great. Great. That makes sense.
P is
Because,
equal to 1 minus.
sorry.
So here 1 minus Ci is something like P is equal to 1 minus Q, right?
Yeah. This is called as level of significance. So I can say level of significance and confidence interval is equal to 1. So level of significance means something there is a significant value that can destroy my success. That is called as alpha. So alpha is probability of our test getting rejected, and success is this 90%. Tejas? Chalo. Let's move ahead with this topic. So these were few small things that you needed to
Wait,
understand.
wait, 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 wait. Slide to the last slide.
Actually, ये जो चीज है ना, what this thing I like made you understand right now. I'm 110% sure when you will go for hypothesis testing, no, this will be at very ease to you, because when you know what is alpha, what is p, so you will be in a very best position to answer maximum of the question, because maximum of the question deals with alpha and p value only. That's why. Okay. So shall I go ahead or wait for you?
You can go ahead.
Okay, perfect. Atiksha ma'am, have you wrote it?
Yeah. Thank you
Great.
so much. Yash.
ठीक है. Point. So what is our like case now, talking about estimation, right? Estimation. So there are two types of estimation. First one is known as point estimation, and second one is known as interval estimation. So let me draw it in a proper way so that you guys can get it. So my first estimation, अरे वाह color भी है. Yeah. So my first estimation, my estimation is divided into two parts. One is known as point estimation and the other one is known as interval estimation. Okay. There you go. I'll tell you what is point and interval very easily. If you want a very approximately or very specific answer or a point answer, that my estimation will be this value. Let's say am I saying that my value of lambda will be 0.912, or I can say 10.912. So this is the exact value that I found. Although this is an estimated one, this is not correct or most accurate value, but this is exact value. So there is a difference between exact and accurate, right? So this is my exact value, that nothing will go more than this or less than this. But it might not be accurate because I have estimated it. My estimation may go wrong. Got it? So when you are specified to only one point or one value, you go with point estimation. But on the other hand, if you are lying, if your estimation lies in a particular interval, let's say my interval lies between 7.19 to mu to 9.18. So I say that I'm not sure about exact point, but I'm 100% sure, or I'm pretty sure that my mean will lie in some range, maybe A to B, right? There will be a range that will be A to B. In that, my mu will lie. So in this case, in such case, what it is called? It is called as an interval estimation. Is it clear to you? I'm trying to relate you with more practical scenarios, that so that you get everything in your head at a very ease. So I hope you are clear with this, right? Shall we move ahead? Guys, shall we move ahead?
Yep.
Yes, yes.
Yes,
Yes.
yes,
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 yes.
yes.
Your acknowledgement is very necessary, yeah. Okay. So talking about point estimation, there are two estimation. Okay, one is unbiased and the other one is MLE. MLE stands for maximum likelihood estimation. Do I need to write it, or you know it and you can write it? It's maximum likelihood estimation. So what's this? So talking about this, one estimate, that is unbiased estimate, and MLE is another estimate. I can say, see guys, to be very frank, estimation in a whole that I learned with the math sir, it is revolving around two quantities. Either you need to find mu or you need to find sigma. These two things only you need to find. Other than that, I did not see in tutorial sheet also that you are going for third approach. Either you are finding mu given other values or not given other values, or you are finding sigma or standard deviation given mu or not given mu. So everything will revolve around these two quantities. So evaluation of these two quantities only. So when we talk about unbiased estimate, guys, be pretty sure that what will be my value of sample mean, what will be my sample mean will be equivalent to my population mean. Got it? And in case of MLE also, what is my sample mean will be my population mean. That is, if it is said that you need to calculate, if in a question, if you are given 10 data, there are 10 data you are given, and you are asked to find the mean or using unbiased estimate. So what you need to do, you need to take the average of the 10 values, and hence you are done with the mu, because you know that my mu, I guess I wrote it in reverse direction. It should be not like this. It should be like mu is equal to x bar. My mean, population mean, will be equivalent to my sample mean. Got it? But this is not true with the variance. So what? How the variance get differentiated here? So in my variance, if I say, it says my variance is 1 by n minus 1 summation for all n, for all नहीं लिखेंगे यहाँ पे because it is not going to infinity, for I equal to 1 to n xi minus x bar whole square. Got it? But in case of Emily, this will be a very slight change, that is 1 by n summation 1 by n I equal to 1 to n xi minus x bar whole square. Got it? ये समझ में आया? Are these two quantities clear to you?
XI क्या है इसमें?
Yeah, xi, see, in a question when it is given, I'll open the question for you. If you ask this, then definitely you'll come to the question also here. Tutorial sheet, question. Let's open it from here only. Yes. Are you able to see this?
Yes.
Yes. So what are you asking? Xi is this. Xi means from x1 to xn, that is last value. All the values that are given, that are xi. Xi means x1, x2, x3, x4 till
Yes, sample.
xn. Got it?
I got it. Got it.
Perfect. Chalo. Let's move ahead. So I hope the point estimation, there are two things. One is to find mu and other is to find sigma. Mu is same in both the cases, and sigma, or we can say the variance, changes. This is variance, guys. Please be very careful in this case. This is variance. So I need to underroot this thing to find my sigma, right? Got it? This is my variance that I'm saying, not standard deviation. If I want to find the standard deviation, I will underroot it. Got it? So
Okay.
I have written here, because see, in this case you can see sigma equal to under root of something and variance equal to same. I hope you are clear with this.
Okay.
Correct? Chalo. uh, Keeping this interval for time being aside, because this is a relatively big topic, so I'll take it on a new page. But before that, I need to make you understand one more topic, that is mean square error. Okay, because in maximum questions you will find this, right? Not this, but it is told that there is some error. See, this is saying a normal error. Here also it's saying error of measurement, because in estimation there is some error. That's why we are estimating. If we get the exact values, then what is need for estimation, right? So mean square error is something. Now, since we can say, since our x bar is equal to population, so what is our sample is exactly our population, do you feel there will be any error? No. I'll tell you why no error, because if there is any error or deviation, definitely our population and sample mean cannot be equalized, right? But if we are given that our mu is equal to x bar or x bar equal to mu, that means there is no error in between. Hence, we got to the conclusion that they both are equal. Hence, the MSE or mean square error for mu is 0. Got it? Got it? Yes or no?
Yes. Yes.
Yes.
Yes.
Now, talking about what this mean square error is. So understand this: lesser the mean square error, the more better is our estimate. Because less, see, this is very easy thing to understand. The less error you will make, the more exact value you will reach. That is what is said. The less MSC value, the more is powerful is your estimate. Now think of a scenario in this both cases, right? In this both cases you have formula. Think wisely and tell me. I have given you unbiased, right? I have given you, or I can say, not directly writing unbiased, I can say there are two things given. One is sigma square. Sigma square is variance, right? Variance of MLE I have given, and variance of unbiased I have given, right? Just check it using these two formulas. Ignore this under root, otherwise you will get confused, right? Yes. This is for unbiased, this is for MLE. What do you think? Where is the chances of error less? What do you think? Or we can say, what is a good estimator? It's good to ask, out of this MLE and unbiased, what do you think is a good estimator? देखो देखो इसको ध्यान से देखो. The answer lies here only in this two.
N-1 unbiased estimate.
Okay, so you are saying unbiased is less powerful or less good estimate. So you are saying MLE is good estimate, right? Whoever, Atiksha or someone else. Okay, let's think it. ध्यान से सुनिएगा सब लोग, है ना? That is very important and it is very easy also. So whenever our denominator increases, our value decreases, right? Correct or not? Correct. So at one place our this is n, and another place the denominator is decreased by 1. So if denominator is decreased by 1, this value will increase by 1. See, ये देखो, ये वाला case, see this and see this. Are they different from each other? They are exactly same. So what is the value that is differentiating? N minus 1 and n. So comparing these two cases, since in this case there is one value less than n, so definitely here denominator is less, hence the whole value will be more. Correct or not? So the unbiased estimate value, or we can say, yeah, exactly what I am saying, that it is more powerful estimate than n because it has a less denominator, we can say. So whatever someone asked, please correct it in your mindset also, and notes also, that unbiased variance will be greater than MLE variance. Got it? Is
I
it
have
clear?
also said this only, na? Can bias estimation is the better.
Acha, my bad, I'm sorry, I may
Yeah.
misheard that. Okay, no
Yeah.
worries. Okay, one more thing that I want you to understand. I'll where should I write it? I should write it here. So for biasness, okay, or we can say, see, I'll take a new page rather, just to Magalar. See, if there are 10 samples, one sample, two sample, three sample, four sample, five sample, six sample, and we all have, we have the variance of all this six samples, right? So definitely we need to calculate the average of this variance, right? And this average of this variance means the estimation, the e of the, what we say, average of this all uh, variances, sample variance. So in case of Emily, if I do the average of all the variance in Emily, that does not get equal to sigma square or variance of the population. Got it? Again, if we talk about sigma square when it is unbiased, it is equal to sigma square of population. So what I'm saying, that all the samples that I've created, if I add them and make an average of them, it will be my population. So it's just a thing for you to remember. Do not much deep dive into it. It won't end up in, you know, maybe in questions or something. So just for your understanding, I have provided you this. Got it?
No, I'm not understood to this. Like,
Can you just make a note of it? That's what I said, because there is no theoretical proof to me right now, so that I can make you understand. But if you want, I can find some good resources on Google and either share you or explain you that. Will it be okay?
okay, okay. I'm just making notes only.
Yeah, yeah,
Yes.
yeah. ठीक है, आगे बढ़ जाए. Guys, shall we move ahead?
Yes, yes.
Yes, yes.
Yes. Okay, that's all about point estimation. Congratulations, we are done with the point estimation now. So let's move ahead to the interval estimation that I wanted you to understand. We have interval estimation. देखो guys, interval estimation is damn easy. Honestly, it is very easy. If anyone feel like the formulas are very confusing, what to do, what not to do, so please listen to this 30 minutes very carefully. Every of your problem may get resolved in this, because we won't go with formula, we will go with the derivation and actual understanding that what is being done here. So it will be a very like great ease to you to understand. So interval estimation says that there will be a range, right? There will be a range. Let's call it that range from A to B, in which our mu or sigma will reside. Mu or sigma will lie. Got it? So there are basically four cases here. Okay, there are basically four cases. So case number one says that we need to find mu given population variance or population standard deviation. So see, if we are given standard deviation, we can calculate variance by squaring. If we are given variance, we can under root. So this quantity are totally dependent on each other. So if any one case we got, other case is also known to us. So case one is to find mu when sigma square and sigma is given. Case number 2. I'll write the case before you, and then we will slowly dig into all the cases and get to the conclusion. Second case is find mu when unknown sigma square or sigma, means sigma square or sigma is not known to you. Is it clear? Clear है सब लोगों को ये चीज? So case number 3 says, case 3 says calculate or find sigma or sigma square, again they both are dependent, given population mean. Got it? And what case 4 says? So case 4 says find sigma and sigma square where unknown quantity is population mean. See, these two cases and these two cases are pretty same. In this case, we are finding mu. In this case, we are finding sigma. So, are these 4 cases clear to you? That what we will be going forward, what we will be learning after this? Are these cases clear to you?
Yes.
One second. Yes.
What once again? What actually you want to understand? These all cases.
Yes. Cases.
Okay, so basically, see that I have told you that there will be 2 things, sigma and mu, that will be playing role majorly. So in one case, you are finding mu with 2 cases, when sigma square or sigma is given, and when sigma square or sigma is not given. Got it? In other
Okay.
case, you will be finding mu, or we will be finding sigma when mu is given and when mu is not given. Simple. These 4 cases are there.
Okay. Got it.
Got it? Yeah, this binary 0001 1011 cases. Okay, got it. Chalo, let's understand this all cases one by one. Case number 1. सब लोग मेरे साथ है ना? Please be with me, because this is something. First case is very important. Why it is important? Because all the 4 cases will go with this case only. So if you are able to understand this case, I am 100% sure that all the cases will be very easier to you. Okay? So let's draw a beautiful graph over here to understand it. So the graph is, yeah, so I'm drawing a graph here. Okay, yeah, here. So this is my line, this is my graph, and there are 2 points now. Okay, there are 2 points. One point is this and one point is this. I call it A and B. I call it afterwards, I'll call it, but at first I'll say that this region, what I say, this region is basically alpha by 2, and this region is also alpha by 2. You are sure with it till now, right? You are sure with it that in this case we do, and the middle is 1 minus alpha. Clear hai ye cheez? And this is z alpha by 2, and this is minus z alpha by 2. Acha, this graph is only associated with case 1. So like listen to this very carefully, that in case 1, when we need to find mu and sigma square is given. Okay, very carefully listen to this. In this case, we go for z test. Ekdam clear? This you need to understand. Okay, if there is case 1, or forget about case 1, when we need to find mu and sigma square is given, do not think of anything, go for z test. Clear hai?
Okay.
Got it? Chalo. Great. So here we need to find this particular value, right? We need to find this particular value. So I am going into derivations. Like guys, there are 3 cases in case 1, and these 3 sub cases will go with all the 4 cases. First sub case is for 2-sided. Second is we say upper confidence interval, and third case goes for lower confidence interval. Guys, एक बार बस understand this, listen very carefully. These 3 formulas, no, you will never learn it, right? You will directly get it. So we'll start with 2-sided first. So what two-sided says? Two-sided says that my alpha will lie on both the sides, here also, here also. Okay, got it? Got it? I am discussing about two-sided, right?
Yes.
So my probability will lie in minus z alpha by 2 to positive z alpha by 2. And this will evaluate to what? This will evaluate to 1 minus alpha, right? Are you all guys clear with this?
Yes.
है ना? ये वाला केस क्या टफ लग रहा है? Is it something that is tough for you to understand? Tell me. Here someone is like Sudhanshu, can you mute? Yeah. I guess this all cases is very handy to you, right? So this formula is understood to you. Now I'll do some calculations. I'll do very basic steps, and you all know this, that we know using Z formula, Z is x bar minus mu by sigma by root n, correct? Because we are dealing with sample right now, right? Do you understand this? Do you remember this formula? Guys, do you remember this? Yes?
Yes.
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 Great. So I'll just put the value here, and what I'll get, see, derivation is very easy. What I'll get, I'll write it x bar minus mu upon sigma by root n z alpha by 2. Okay. Abhi dekho, I need to find this mu. So I'll free all the entities which are associated with them. So first of all, I'll multiply sigma by root n on both the side. So what I'll get minus z alpha by 2 into sigma by root n less than x bar minus mu. If I multiply sigma by root n here, sigma by root n and sigma by root n will cancel out, and third quantity I'll get sigma by root n. Clear hai ye? Is it clear to you?
Yes.
Yes. Talking about the next part. Now, what I need to do, see, first of all, I need to make this quantity or entity as positive, right? I need to make this entity as positive. So what I'll do, or okay, let's do this. I need to get rid of this x bar, correct? Guys, listen very carefully. I need to get rid of this x bar. So what should I do to get rid of this x bar? What can I do?
Add x bar. I mean, subtract x
Minus
bar.
plus
Perfect. If I subtract, see, I'm writing here. This is a dashed thing. If I subtract, ये क्या हुआ? Sorry, the subtraction go wrong. Yeah. If I subtract x bar from here, I'll be left with only minus mu, correct? So I'll subtract x bar from this whole, we can say limit. So what I'll get, minus z alpha by 2 into sigma by root n minus x bar minus mu and z alpha by 2 sigma by root n minus x bar. Correct? Guys, are you with me till here? Because we are left with only one step. Now see, I need to get rid of this minus, and you know, whenever this is the condition a, x and b, and I need to change the sign. So this will be minus a, this will be minus x, this will be minus b. Along with it, the equality will also reverse. Got it? This is a formula, or this is a basic tool that we use, right? So I'll do this here. What I'll do, I'll first of all minus it. So guys, if you see this, can I write this minus of this plus this? Can I write it?
Yes.
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 And if I subtract, if I multiply minus on all the sides, I'll get z alpha by 2 into sigma by root n plus x bar greater than mu greater than. Now minus of this entity will reverse, and this will be x bar minus z alpha by 2 sigma by root n. This is clear? देखो बहुत easy step है, nothing hard. Got it?
Yes, the previous step is that you have done minus for all the.
Yeah, I multiplied -1 into whole range. So this minus become plus, and this X, see, a minus b and minus of a minus b becomes b minus a, right? So that's what I did. A minus b of minus, it's become b minus a, right?
And along with that, both the signs have also changed, right?
Yes, both the sign has changed. So what I'll do, I'll just do a mirror image of it. So see what I have written. I have written here 5 is x is 2. So I can write this 2x 5. Can I write this? Do you understand changing of this? All of you. If anyone has issue, I can explain you again this.
Yes.
This says 5 is greater than x and x is greater than 2. That means 2 is less than x and x is less than 5, right? So this way I'll do this also. And what will be the final conclusion? I will come. So where should I write this final conclusion? I shall write it here. So this will be first. So it will be x bar minus z alpha by 2 into sigma by root n less than mu less than x bar plus z alpha by 2 sigma by root n. Correct? Correct? Is it clear to each one of you?
Yes, yes.
Each one of you, because this is very important, guys. If out of 18 there is at least one person who is not clear, I'm ready to explain, because all the 4 cases, all the 3 cases, I'll be doing the same thing. Okay, so no responses from your side. So I hope that you all are clear with this, right? So in what interval will my mu lie? So my mu will lie in the interval x bar minus z alpha by 2 sigma by root n to x bar plus z alpha by 2 sigma by root n. Chalo. Thank God we are done with it. Now talking about case 2. Sub case 2, basically. Sub case 2, that is upper confidence interval. अभी जिसको भी कंफ्यूजन लगता है ना, अगेन लिसन टू दिस वेरी केयरफुली. दिस विल क्लियर ऑल योर डाउट्स. Okay, so again I am drawing this and I am saying my graph is going like this. Got it? And I have some point. I have a point here. I knew it. Yeah, I have a point here that is z alpha, and this region that is lying here, it is alpha, and the whole region here, it is 1 minus alpha. Is it clear to all? This is one tail, right? First one was two tail or two sided. This is one tail, right? Because only upper or only lower we are looking into. Got it? Got it? Abhi dekho, one thing that I
Yes.
need, that I want you to understand. Dekho, very easy. I'm making it very easy to you. See, in two sided there are 2 points, right? A and B, right? Correct. अभी सोचो कि if this A point was not there, so this B would have been a standalone point, and this will lie alpha and 1 minus alpha. Correct? So can we say this Z alpha is my B point? Can I say this, guys, quickly?
Yes.
Yeah.
No, yes, you need to repeat it.
Yeah, guys, are you understanding, right? Because yeah, you are understanding. Okay, got it. Many thumbs up. Yeah, I'll repeat this. When you see this two-sided, see this two-sided. Here it is drawn. See this two-sided. This is point A and B. Imagine, think of a scenario where this A point wasn't there. It wasn't there, right? This point wasn't there. So entirely the range would fall into this one line. In the case 2 that I am discussing, पूरा का पूरा इस पे ही lie हो जाता. So this would be a common point for both the, like, for differentiating. So can I say that this is a B point? Z alpha is a B point here. Can I say? Yes, I can say it. So, and since I do not have lower bound, my lower bound will be minus infinity. Correct? Is it clear? Because there is no range here. So my mean will lie from minus infinity to mu to, sorry, yes, minus infinity to mu to basically z of B or z of alpha. Correct or not? Tell me this thing. ये चीज, is this clear to all?
Yes.
Yes. Again, putting the same theory, same formula, mu is equal to x bar minus mu by, oh, sorry. This will be z. Yes. So my so my z is x bar minus mu by sigma by root n. So I'll write p of minus infinity x bar minus mu into sigma by root n. देखो अभी guys, those who did not understand the last derivation or missed anywhere, you can again check here. First point, first step, what I will do, guys, come on, together with me. तभी आपको लोगों को समझ में आएगा. What I will do, say it. Multiply sigma by root n on both sides. So multiplying anything into minus infinity won't do anything. It will be as same. This will be like this, and z alpha direct sigma by root n. Sudhanshu, can you mute, guys? Okay. Now what I'll do, second step. Come on, all of you with me. What I'll do? Quick.
Minus x bar.
Minus x bar.
Minus
Correct.
x.
So, something adding into minus infinity won't affect, but it will be minus mu, and I'll get z alpha by root n minus x bar. Correct? Chalo, quick. Point number 3. Derivation. Point number 3. What? Come on, guys, fast.
-1 both sides, and then
Correct. Multiplied by
reverse
minus
the
1. So this in minus infinity will become plus infinity. This will be greater than. This will be mu. This will be greater than. And this will be minus of z alpha sigma by root n minus x bar. Correct?
It
So this
can
will
be.
be. So this will essentially be x bar minus z alpha sigma by root n. Correct or not?
Yes. Correct.
Yes. Now last step, what I need to do? Mirror image of it, or just rearrange it. So my range will be z alpha into sigma by root n comma infinity, or I can say less than mu less than infinity. Is it clear to all of you? This formula, is it clear to all of you?
Yes.
Understood. Yes.
Understood? Understood?
Yes. Can you go to the previous? Can you, Can you
Yes.
go to previous slide once again?
Got it?
Okay. Got it.
Yes.
Yeah.
Okay. Guys, did you got this? What we were discussing? Did you got this thing? Did you understand this?
Yes.
Upper confidence interval. Okay.
Yes.
Abhi dekho, after explaining lower confidence interval, no, you will forget. You need to forget this formula and everything you remember. Don't worry. अब भूल भी जाओगे ना, तो you won't mug up in examination because you have the solid, conceptual understanding. So subcase 3, if I talk about, so my subcase 3, what it says, again, I won't go into my drawing now, and it says that this is some case, and at point here I'll get my lower confidence interval, right? So this will be 1 minus alpha, this will be alpha, and this will be minus of z alpha, right? Because in our normal graph we have z alpha by 2 minus z alpha by 2. That means this point will be essentially a. अभी think carefully, यहाँ पे alpha by 2 नहीं आ रहा है. We are not getting alpha by 2 here. Why? Because there is no two-sided, only one-sided. That's why either way it is alpha, other ways it is 1 minus alpha, right? So you got this minus z alpha. Did you got this? If you got this, then only we'll proceed further.
Yes.
And till where it is going to infinity. So what formula I'll start it? Again, I'll start it. My probability of 1 minus alpha lying, or my probability of z lying, is falling between minus z alpha to z to infinity. Correct or not?
Yes.
Chalo, guys, very quickly, step number 1, compute the formula of z, that is x bar minus mu by sigma. Correct? Got it?
Yes.
Step number 2, substitute it. Step number 3, come on, guys. You need to say it again and again so that you remember it.
Multiply
Yes.
sigma by
multiply sigma by root n on both side. And in infinity, will it make any change? Definitely no.
No.
Fourth point. Quick. Minus x bar. Abhi hai na, you are in that position that if you close your eye, no, you can easily say the next thing because you have done it more than 2 times. I assume that you will
Minus
be
1.
in that position. So point number 5, minus 1 in multiply, correct. So it will be, guys, listen to this carefully. Minus and minus, I am doing this plus. Please do not ask again because it is very simple that we are doing here. Correct or not? Correct? Correct. Last step, reorder. क्लियर है सब लोगों को ये चीज?
Yes, yes.
Did you got it? अभी देखो है ना?
Yes.
How to learn this? How to remember this for life, right? Entire like when you until you want. So देखो two-sided tail का case का देखो. For two-sided, what was the formula, right? What was the formula? Formula like my range was lying between x bar minus z alpha by 2 into sigma by root n to x bar plus z alpha by 2 into sigma by root n. Correct है? Correct है? Two sided was lying this. Correct or not? Correct. अभी देखो my lower confidence interval where it is lying from minus infinity to to x bar plus z alpha sigma by root n. Correct or not? Correct or not? Correct है?
Yes.
And my upper confidence interval till where it is lying from x bar minus z alpha sigma by root n to infinity. Correct? यही 3 cases है.
Yes.
Why I made you understand this as A and B? Okay. Why I made you understand the point A and B? First of all, learn this. If you are talking with lower confidence interval, because it is low, okay, because it is lower, it will start from minus infinity. Correct? And because it is upper, it will go till infinity. ये चीज clear है सबको? Or should I say again?
Clear.
Clear है. If we are dealing with lower, it will start from minus infinity. If we are dealing with upper, it will go till end. अभी we just need to understand ये क्या value होगा, right? ये क्या value होगा? So listen to this very carefully. If we are dealing with lower, my range will go from minus infinity to B. And if I am dealing with upper, my range will go from A to infinity. Got it? Got it? अभी B मेरा क्या था? ये B था. So when I am talking about lower, see, I have written the same, just alpha by 2 को alpha से replace किया because it is one-sided. Other than that, everything seems same. Correct? Correct or not?
Yes.
Yes. When talking about upper confidence interval, I know my last range will be infinity. I learned it now. But what will be my starting point? It will be A. A means start this one. So that is x bar minus z alpha sigma by root n. Clear है सबको? Clear सबको?
Yes.
All of you, I hope this made you relatively easier for you to understand and learn this thing, right? Yeah, sure. Okay. Great. So in this case, you are able to understand all these 3 cases just by one case. You remember this formula, you derive this formula, and you also know how to derive this formula. So where is the point to remember? Do you feel any point that you need to remember this? I hope
Just a graph.
it's just a graph. Exactly. That's what I told. If you are good with concept or if you are good with graphical understanding, I hope this whole topic that I taught you, know, any one of you can teach once again. That is the power of understanding the graphically concepts graphically or visualization. Got it? Perfect. I hope this is understood to you. So with this confidence in you, I'm going with next scenario. So before that, I'm just writing here. So for case one, okay, for case one, what will be my two-sided? Can you all say it with me? Can you all say it with me? What will
This
be
is
my the range?
case first of what?
Yeah, only for case one I am writing. I'll in this sheet I'll summarize all the cases. That's why I've written here. So for
Okay,
the
four of
first
the
case,
cases, no?
yeah, for first case, what it will be? Can you all recite it with me? It is x bar
X
X bar
minus
minus
Z alpha by 2
sigma by
sigma by
root,
root n
and root n.
and other one is
X
plus
bar
alpha
of it.
plus
plus
Perfect. Okay, good to see that confidence in you. What will be the lower? Okay, so lower के लिए do not need to write learn anything. Just think lower मतलब कहाँ से? When from where it will start?
minus infinity
Perfect. And
minus
till where it
infinity.
will go? Till B it will go, and B
B
is
B X
yes.
bar
So it will
Z
be
B
plus Z alpha by
X
2
bar plus
alpha,
Z
not
by
alpha by 2.
Z alpha
Alpha.
sigma by root.
Got it? And for the upper interval, what it will be?
X bar minus
X
Z
bar minus Z alpha
sigma
sigma
by
by
root
root
2.
n till alpha.
ठीक है?
Yeah.
I hope what I promised I succeeded in it, and you all got understanding of this case one. So let's go on. Case two will come on this sheet again when we complete this case two. It's 11:15. I hope in 15 minutes we'll cover this case two also, and we are and if you allow, we can go ahead. If you do not, we'll go tomorrow. ठीक है? चलो case two, what it says find mu when sigma or sigma square is unknown, right? Okay, only one thing you need to remember here, that here we use t-test. We do not, oh sorry, t-test नहीं बोलूँगा. We do the evaluation using t table, student t. Okay. In first case, when we were going for z distribution, we will here go for t distribution. Okay. Just ये याद रख लो यार, and please do not ask that to me because I need to learn that. It's relatively easy for you. First is z, second one is t. Okay. So for the two-sided, देखो, what will change? See this. कितना इजी होगा आपके लिए याद रखना. फॉर द टू साइडेड व्हाट विल बी द फॉर्मूला? अच्छा, टू साइडेड के लिए z का क्या फॉर्मूला था? सॉरी, केस वन में क्या फॉर्मूला था टू साइडेड का?
X
कैन यू से
bar
इट अगेन? x
X
बार
bar minus Z
Minus
alpha
Z
by 2
alpha by 2
sigma by
sigma by root n.
yeah,
Okay.
just the plus sign.
plus sign. Now what change here? From z it changed to t. Right?
Mm-hmm.
From z it changed to t. So what I'll write here, I'll write x bar, or let's not write it down. Let's write it there only. Right? So instead of z, what I'll write?
T.
I'll write t. Simple. T. And when we deal on t, we also need to introduce n minus 1 also.
Yeah. Freedom. Degree of freedom.
Degree of freedom, where n is degree of freedom. DOF means degree of freedom. Okay. So बताओ अब मुझे कि with this have that maturity to answer me upper level. Upper
Yeah.
bound क्या होगा, और what we can say upper confidence interval क्या होगा? Again,
Plus
upper
alpha by
confidence
2.
interval कहाँ तक जाएगा? First of all,
Infinity.
Infinite.
okay, and from where it will start? We remember a to
A.
infinity minus infinity to b, right? So what
So
is
we
a?
directly write X
X
bar
bar
minus T
minus
alpha
alpha
n
by
minus
2 n minus 1
not 2
sigma by root.
n minus.
Yeah, all of you who think of alpha by 2 do not think of alpha by 2 because upper
It's
confidence
a
interval
one-sided.
deals with one-sided. Got
Hmm.
it? And again, for lower confidence interval, what it will be?
Minus infinity. So we'll start until go B. X alpha. Yeah.
Is it anywhere tough to you? Because I hope you guys told me the formula and not I told you the formula, right? Right?
Yes, yes.
Yes. So let's go and fill the case 2 also.
Wait. Yeah. Just a second.
Yeah.
Just one.
Sure. I'll give you that time. Don't worry. Hungry. ज्वाइन हुई थी ना? Okay, let it be. चलो. What do you want this one? Case 2.
Yeah.
Yes. ये तो आप मैडम बिना देखे लिखो, फिर वेरीफाई करो कि what you wrote is here or not.
Okay, you can change. मैं लिख लूँगी.
Got it? आगे बढ़ जाएं?
Hmm.
चलो यहाँ पे बताना मुझे, ठीक है? Because we are writing it again here. For two-sided, what it is?
Yes, yes.
हाँ.
Yes, can you go to previous slide? The T1.
Take your time.
Yeah. So why we are using T n minus 1? I mean alpha by 2 n minus 1.
Because when we deal of T
Okay,
distribution,
degree
no?
of freedom.
Yeah, there are two quantities in picture. One is
Yeah.
alpha and one is n. That is degree of freedom. Got it? Quickly.
Yeah.
Two-sided का formula. चलो. All together.
Yeah, x bar minus t alpha by 2.
Z. अच्छा T. Okay, great. चलो. My fault. X bar minus.
t alpha by 2.
एक मिनट, मेरा पेन नहीं आ रहा. हाँ. T alpha by 2.
n minus 1.
Sigma by root n.
n minus 1.
N minus 1
Yes. And x
X
bar
bar
T alpha by 2, comma
plus.
n minus 1.
Sigma by 2.
Yeah,
Correct है?
yeah. Now opposite.
Correct है?
Mhm.
Yes.
हाँ.
अच्छा, एक चीज यहाँ पे थोड़ी सी चेंज करनी है, थोड़ा सा. I told you that this is unknown, right? If this is unknown, how can we write sigma here, right? So we won't go with sigma in this case because our is unknown. We will go with sample standard deviation.
S.
Got it? छोटा सा change. Yeah, we will go with S. We'll
Yeah.
go with S. S is sample standard deviation. Guys, all of you, be careful with that. Okay? And यहाँ पे भी क्या आएगा? सिग्मा की जगह S आएगा. Right? आप लोगों को समझ में आया? Why did I had these changes? Because in
Yes.
case number 2, it is defined only in the case when the population standard deviation is not given. So how we will implement it into our formula if it is not known, right? What is for lower? So do not directly jump on formula. Go gradually.
Let's
For
go.
lower, it starts with
A.
minus infinity, and it
Minus
goes with
infinity.
b. That means x bar plus t alpha
Plus T bar
n minus
n
2
minus
s by root n.
S by root.
Correct. And for the upper, what it is?
From A, which start till infinity.
X from T by alpha n minus 1 S by root n.
S by root n.
Frankly, how much time we spend in case 2? Not more than 5 minutes. I started at 11:16. We concluded at 11:22
Mhm.
because we were clear with case 1, right? So 2 cases are clear to us. Now we'll go for case 3, right? Case 3. Let's go open a new sheet. And case 3. So what is case 3? Now we need to find sigma, or when mean or population mean is known, right? हमने एक वो बनाया था, where it is 4 cases I wrote. ये रहा. See, we are done with this case. Now we are on this case, right? We are on this case. So again it is very easy. It is not at all tough because you got one understanding. So in this, what we do, we won't go for Z test, we won't go for T test, we will go for chi-square test. Okay, chi-square distribution we go for this in this case. Got it? And for this, we write a formula W star equal to summation of I equal to n, 1 to n, and I write it xi minus x bar whole square upon sigma. Got it? And this follows chi square n. Please understand this very carefully. Case number 3, where mu is known, it follows n degree of freedom. Very important, highlighting factor, highlighting concept. This follows n degree of freedom. केस 3, ठीक है, क्योंकि केस 3 में n-1 होगा, इसलिए और कुछ भी चेंज नहीं
यहाँ
होगा.
पे x बार होगा या फिर म्यू होगा?
देखो, म्यू होगा, एक्स बार नहीं होगा, म्यू होगा. यू आर राइट. Yes, I'll get mu because mu is known, so we do not need to go for x bar. Just a minute, guys. I hope this got disconnected. Just give me a minute, guys. Let me reconnect it. No worries. We'll start on different. Yeah. Okay. So case number 3, what it says. Anyone wrote anything? Yeah, Sandeep, please can you mute your microphone? Okay. So case number 3, what I was telling, I'm writing it here. So my case number 3, what was it? It was I was finding the W star, and that was equivalent to sigma summation of I to I equal to 1 to n xi minus mu whole square upon sigma, and this square is included in it. And this strictly follows chi square n, right? अभी टू साइडेड के केस में क्या होगा, है ना, ये याद रखिएगा, ठीक है. टू साइडेड, फॉर टू साइडेड केस what we will do, so for two sided case I'll get the result that is, यहाँ चल जाएगा तो अच्छा है. हाँ चल गया, चलो. ओके, for the two sided what will be the formula? It will be summation I equal to 1 to n xi minus mu whole square upon sigma square. If I write this or this all, these both are equivalent. I'm just distributing square down. And okay, one thing very important, because we did not draw the graph, then how can we conclude? Because our USP was graph only. So when we talk about chi-square distribution, no, there is nothing called minus infinity here, because our graph starts with 0 and goes to infinity. Got it? And our 2 points will lie here only. So unlike this one, the Z table, I'm distributing like the Z distribution we were discussing. I was distributing as alpha by 2 and alpha by 2, but here I won't distribute in this way. If I have alpha by 2 here, my other will be 1 minus alpha by 2, right? This will be my point for two sided also. This will be my 1 minus alpha by 2 point. This will be my alpha by 2 point. In two sided test case, if we say, got it? So
Yes, why it is 1 minus alpha by 2?
see, ma'am, this graph is not symmetric. Point number 1. Got it? This graph
Okay.
is in no way symmetric. If it would be symmetric, we can say half is divided here, half is divided here. So out of that alpha, or we can say, okay, I'll tell you. Dekho, this alpha by 2 and alpha by 2 adds up to alpha, right? Right? Now in this case, if we are divided, like we are taking this as alpha by 2, this won't be this won't be alpha by 2, right? This won't be alpha by 2 because they are not symmetric in nature, and hence we get it as 1 minus alpha by 2. I'll get more clarity on how we get 1 minus 2 alpha 1 minus alpha by 2 only and not the other quantity. I'll definitely share it with you tomorrow, but for today I request you to like understand this, that it
Yeah.
will go with alpha by 2, 1 minus alpha by 2 over 2.
So
Okay, sure.
simply, her
Yeah.
Yash, the whole will be the
No.
one, right? So it is a
Yes, yes,
one-sided.
yes.
So it will be alpha 1 minus
Ma'am,
alpha
I'm
by 2.
discussing
Simply
about
it is
two-sided here, not one-sided. Right?
okay.
And if we add this and get one, so where this quantity will go? Got it?
If we add
If we add this
okay.
area and this area and evaluate to one, where will this go? That's why I'm not in the position right now to give a concrete reasoning behind it. Okay?
Sure, sure. As of now, we'll just remember this.
Yeah. Yes, yes, yes. That is much better for me also. Okay. So what it will be, what my formula will be, or let's say just wipe out this graph for now. It will make you more confused. Okay, it will make you more confused. Just नामो निशान मिटा दूंगा. Okay, got it. So what my formula is for two-sided, it is summation of xi minus mu whole square. Got it? And this is also mu whole square upon chi square alpha by 2 comma n. Okay, got it? Chi square alpha by 2 comma n. This is the case. And the upper limit will go I equal to 1 to n xi minus mu whole square upon chi square 1 minus alpha by 2 comma n. Why 1 minus alpha by 2? I hope I like made you some just assumptions and got you to this point. Okay, if you know these two formulas, it will be very easier for you to define the lower confidence interval. Correct? Lower confidence interval, guys. Once again, lower means where it will start.
0.
Minus
Zero.
infinity.
Correct.
0.
Because in this case there is no in minus infinity.
Okay.
Its range starts from 0 to infinity, right? So our lower interval starts from 0, and what is told in lower, it is from 0 to b, in upper it is from a to infinity, right? Correct. So it is from 0 to b.
Yes,
That means,
yes, I
sorry,
have one. It's two-sided. The first value comes for B and second value comes for A. Is it something like that or it's right?
no, a and b only. That's why I removed this graph, so that you do not get
Okay.
confused. That is the only reason why I removed that graph. Okay. Actually my point was not to to plot the points of alpha. It was more generic towards letting you know that it starts from 0 to infinity. That was my first point of impression to you, but other way, when I move forward, I felt like you may get confused. That's why I removed it. Okay, so it will go till b. So b will be summation I equal to 1 xi minus mu whole square upon chi square. यहाँ पे क्या लिखूंगा? What I'll write here?
1 minus
1 minus
alpha by 2 comma m.
alpha.
Oh,
Because
alpha by, sorry, alpha comma m.
correct. And what is upper confidence interval? Come on, guys, quickly. Everything is in front of you.
Summation I1 to n xi minus mu का whole square upon chi square alpha comma n.
Right?
Okay.
Correct. Got it? Guys, did you
Okay.
got it?
Yes.
Yes, yes.
Shall we write case 3 here? Okay, I need your help because I am also not good at remembering the formulas. So what is the formula? It is summation I equal to 1 to n xi minus mu whole square upon chi square. What it is?
alpha by 2, comma n.
Perfect. 2 summation I equal to 1 to n xi minus mu whole square upon chi square 1
1
minus
minus
alpha by
alpha,
2 comma n.
By
Correct?
comma
Chalo. Lower confidence interval. Lower starts with
0.
upper ends to b base. Correct? Got it? And how will
Alpha
my
रहेगा ना,
upper go?
alpha by 2.
Sorry. My fault.
Yeah, alpha.
This will be alpha. Alpha ही तो लिखा
And
है.
yes, what about degree of freedom?
N,
Will it
N,
be n
N, N,
minus
N,
1 or
N. Remember, in case 3, that's why I have highlighted it in red. There are n degree of freedom. Got it? I'll tell you why I highlighted. I'll tell you.
In case
Just
2,
give
it was n minus 1, right?
Yeah, it was n.
No,
No,
case
no.
2 is
What I'm
asking n
asking is
minus 1.
Yeah, previous one.
in
Case 2,
case
it
2,
was
it
n
was
minus
n
1.
minus 1, right? Degree
Yeah,
of
it was
freedom.
n minus 1, but it is here it is
Okay.
n. Got it right? Perfect. चलेगा? Guys, चलेगा सब लोगों को?
Yes, understood.
Yes, yes.
Yes. Only case number 4 is left, and this is very similar. We need to estimate or find sigma or sigma square when mu is not known. When mu is not known. Mu is not given, that means what will be given? X bar, sample mean will be given, right? So here, nothing we will do. Just you can recall the formula of W star there. It was summation of I equal to 1 to n xi minus mu whole square upon sigma square. You remember there? It was the same, right? अभी इधर क्या हो जाएगा? This W star will get converted into W. This mu will convert it into what?
X bar. X bar.
X bar, because mu is not given. Other than that, everything is same. Chalo. And here it will follow chi square with degree of freedom n minus 1. This is the reason why I highlighted there. Case number 3 में degree of freedom will be n. Case number 4 में degree of freedom will be n minus 1. Why it is n minus 1? Because degree third वाले case में we were dealing with population mean, and in fourth one we are dealing with sample, and when we are dealing with sample, there is one loss of degree of freedom. Got it? Got it? Chalo.
हाँ.
Two-sided का formula.
Can you explain the last concept on that?
Yeah, my last concept was saying that in case number 3, our main mu was given. That means population mean was given. That's why we use directly complete all n degree of freedom. But when here we are going for sample mean, right? That's why we lose 1 degree of freedom and it comes to n minus 1. Got it?
Okay.
So what is the formula of in case 3? Can you remember and can you frame it here? So it used to say summation I equal to 1 to n xi minus, there was mu, here it is x bar, upon chi square 1 minus alpha by 2 or alpha by 2?
Alpha by 2.
Yes, it was alpha by 2. And how many degree of freedom?
N minus 1.
Perfect. And last range of it, xi minus x bar whole square upon chi square 1 minus
1
alpha by
minus
2
alpha by 2.
to
N
n.
minus 1.
Got it? चलो lower बता दो. तो lower will start from 0
0.
to p. मैं इतने बार लिख लिया ना इसे कि I learned it. If you all wrote it, you will also will be in that position to learn. क्या लिखूं यहाँ पे मैं?
1 minus alpha
1 minus
Perfect.
alpha
and minus 1.
combined.
Perfect. So just the thing, write it as much as you can, and you will remember it forever. करेक्ट, गॉट इट? चलो
हाँ
एक बार और आपको लिखना पड़ेगा, एक बार और हम लिखेंगे एंड वी विल एंड अप दिस. सो इन केस 4 where we need to find sigma and sigma square where mean is not given, what is the formula for two-sided? Summation xi minus x bar whole square upon chi square
alpha by 2
comma n minus 1
and minus 1
summation xi minus x bar square upon chi-square
1 minus
alpha by 2 comma n minus 1. करेक्ट?
minus 1. Correct.
लोअर इंटरवल के लिए क्या होगा? लोअर इंटरवल से 0 to
0,
summation xi x bar square
Okay.
chi-square 1 minus
1
alpha
minus
by 2 n minus 1, sorry 1 minus alpha.
1 minus हाँ
1 minus alpha. And upper interval, what it says? It says it starts with xi minus x bar whole square upon chi-square alpha n minus 1. Until where it will go? It will go till infinity. All 4 cases are covered, guys. Trust me, all 4 cases are covered. Your entire tutorial sheet has been covered. 9 questions are from here only. Nothing goes out of this boundary. So first thing first, I hope okay, this is the perfect time to end the class. Before that, I want to understand did you all understood this, right? All the 4 cases and estimation theory.
Yes. Yes.
Yep. And all the formulas are also clear. You are not mugging up any formula. You are just learning one formula and making all the formulas out of that one formula, right? In case number 1, we learn one formula. We derive all the 6 formulas of case 1, case 2. In case 3, we learn one formula and derive all the 6 formula for case 3, case 4, right? So tomorrow I'll directly start with tutorial sheet. I request you all that you at least solve some questions of tutorial sheet 4, or maybe 9 questions are not that much, not that much quantity of questions. So you solve all of them, and when we will be discussing tomorrow, it will be more healthy discussion rather than one-way communication. Is it okay to you all?
Okay.
Yes.
Yeah, guys, I end up this class here. I hope you understood. Any doubts, if you have,
Yes.
you can ask me.
Yes,
Okay?
I have
Yes,
one
Arshad.
doubt. Graphically, you can show where we can say degree of freedom. मतलब जो अपन n दिखाते हैं, right? तो ग्राफ में वो कहाँ पे आएगा?
हाँ.
सिर्फ वो देखना था मुझे. बाकी मतलब पूरा समझ में आ गया.
ओके. यार ग्राफ वाला ना मैं आपको कल बताऊंगा. जो मैंने आपको बताया था ना केस 3 वाला जो ग्राफ में वो था, मैं आपको बोला था कि मैं पढ़ के बताऊंगा. Actually, n is lying into that only, right?
Okay.
Because degree of freedom we did not covered in any of the cases. So I'll check the degree of freedom and I'll let you know, right?
चलेगा.
Degree of freedom, according to me, what it is basically, degree of freedom definition is that कितने variables involved हो रहे हैं हमारे किसी आंसर को निकालने में. Got it?
कितनी categories are there? Like how many categories are there?
Yes,
That
correct. How many categories are there? Thanks, Diksha. So कितनी categories है? तो in that case मैं आपको graphically तो I am not sure मैं आपको कैसे कैसे show
Categories
करूँगा.
मतलब see on
Like suppose-
x-axis we can plot categories, right?
हाँ. जैसे age मान लो 0 है. फिर
Okay.
18 to 20, then 20 to 35. So there are the 3 categories.
So means infinity की तरफ जाता है, right? So
हाँ.
कितना दूर तक जा सकता है kind of that is n
99 तक तो मैंने देखा है.
Okay.
हाँ.
क्योंकि मैं वो जो अपने को टेबल मिलेगा ना वो 99 तक
Simply
मिलेगा.
इतना याद रखना कि category is what n is.
Okay. ठीक है, समझ
Okay,
में आ गया।
variable you can see. हाँ, बस वो इतना सा माइंड में रखना तो फिर क्लैरिटी मिलती है।
ठीक है, मतलब इतने पूरे लेक्चर में मैं ज़्यादा डाउट नहीं पूछता हूँ, पर यही अचानक से दिमाग में आ गया
मैंने तो
कि
पहली बार आपकी आवाज़ सुनी भाई।
अरे ज़्यादा बोलता भी नहीं, थैंक यू भी नहीं बोलता मैं कभी कभी।
It's okay यार, I can understand यार, thank you without verbal.
नहीं, पर आज के
चलो
लेक्चर के लिए थैंक यू भाई, बहुत सही पढ़ा है यार, मतलब सारे लेक्चर सही पढ़ाता है, पर आज का मेरे को बहुत ज़्यादा समझ में आ गया।
चलो great, happy to
ठीक है,
hear that.
yes.
Okay guys, feel free to drop any question if you feel like, or any queries, doubts, and we will connect tomorrow at the same time with same case. Okay.
गाइस रिकॉर्ड किया ना सबने सेशन? आई जस्ट जॉइंड इन, लाइट चला गया था तो।
Yes, हर्षल ने रिकॉर्ड किया है।
Yes, recorded.
हर्षल प्लीज शेयर करो ना रिकॉर्डिंग, है ना?
Yes.
आई विल वॉच इट नाउ। चलो थैंक्स यार।
Thank you.
so much, Yash.
Thank you.
Thanks,
Thank you.
Yash.
Thank you. Thank you.
Thank you, Yash
Thank
bhai.
you.
Thank you, yes.
Okay.
Thank you very much, Yash.